Okay, so let's look at some things to do with quadrilaterals and triangles. That's going to be the next part that we're going to look at. So a quadrilateral is, or we'll get into our definitions, I suppose. So polygon is a closed-sided shape with straight sides and at least three sides. Okay, a regular polygon then has equal sides, equal angles. A quadrilateral then is one that has four sides, so quad, that kind of word for four. Parallelogram is one where both pairs of opposite sides are parallel. So you have obviously what we would normally talk about being a parallelogram, but we also have then a square or a rectangle, okay, where the opposite sides would be parallel to each other. A vertex is a point where two or more lines meet, and what we call a convex quadrilateral is a four-sided polygon where all the angles are less than 180 degrees. So you might have a particular four-sided shape where maybe one of the angles is going to be bigger than 180 degrees, and then the rest of the sides would be smaller. So something you could have something like that potentially. Although more than three, 1, 2, 3, 4. Okay, let's get rid of one of the sides. So maybe something like that. Okay, so looking at our kind of common quadrilaterals, I suppose again this is all in your notes and something just for you to go over. You should know the different types of quadrilaterals, how their sides interact, what sides are parallel to each other, what angles are equal to each other, how are the angles related, are opposite angles equal, are all angles equal, what happens with the diagonals, do they bisect each other, do they bisect each other at a right angle, different things like that. These are all things you should know for all these shapes because you're going to need them to answer your questions then. Next things to know, I suppose, area of a triangle, area of a parallelogram. So area of a triangle is half by the base by the perpendicular height. Area of a parallelogram is base by perpendicular height. The only kind of extra part here with your triangle is if we have a triangle like this, then your perpendicular height can be on the outside here. Okay, the height from the top point straight down to in line with the base, so that it would be perpendicular with the base. So you can't just draw a line like that because that's not perpendicular to the base. So that's the only kind of area that we can kind of cause issues with this. And then your parallelogram is base by perpendicular height. So again, that height being the straight line that is perpendicular to whatever you've chosen to be the base. And it's important, I suppose, with the triangle there as well, that it doesn't matter which side you choose to be the base of the triangle. So if you have a triangle like this one here, and if you decide that this is the base and you take your height here, that's perfect. If you decided that you wanted to choose this to be the base and you had your perpendicular height like this one, that would also be perfect. Okay, it doesn't matter which side of the triangle you choose to be the base, so long as you are consistent with the fact that you use the base, and then the perpendicular height, the height has to be perpendicular to that base side. That's the main thing. Looking at the next part then, so we're looking at an exam question that uses some of that. So the area of this parallelogram is 480 meters squared. We're asked to find the area of the triangle ABD. So looking at the shape, we can kind of eyeball and think, well, it looks like it's about half, and you'd be correct in thinking so. So the area of the triangle ABD is half the area of the parallelogram ABCD. So half of 480 would be 240 meters squared. Okay, looking at part 2 then, we're told that E, which is up here, is the midpoint of CD. Find the area of the triangle BCE. So E is the midpoint of my line CD. So how is that going to help us in terms of answering this question? Okay, so let's have a look. So BCE, let's draw in our triangles. So I'm drawing down from B, and I'm drawing over then to C. Okay, so if we look at the triangle that we've drawn, and something similar to what we said earlier, was that your perpendicular height has to go from, say, the top point of the triangle down to what we consider to be the base of the triangle. So say we take from this point here, if it was straight down, it would have to go straight down here so that it falls perpendicular to where the base would be. So it's essentially perpendicular with the line that the base is on. So we could take that to be the height of this triangle if we took CE to be the base of the triangle. What we should notice here is that that height would be the same as my perpendicular height for my parallelogram. Okay, that height is going to be the same. So looking at my area of my parallelogram, the area of my parallelogram ABCD is the base times my perpendicular height. We know this area is 480 meters squared. I don't know what my base is, I don't know what my height is. Okay, but we could say that my base is 480 divided by whatever the height is. Okay, whatever the height is, we're not really sure, but it doesn't really matter for this one. Okay, or equally, what we could do actually, instead of having it that way, let's leave the height as the one that we know. So we know that the height for this triangle is 480 divided by the base being the length from C to D, or A to B there. Okay, either or. We might need to switch that one round, but let's just kind of work with it for the time being. So looking for my triangle CBE then, so if this is E, this is C, and this is B, let's try and kind of relate what we're looking for. So we have that our perpendicular height is going to be the same here. This is going to be H. This distance here from C to E, that is actually half of the base. If we take my base to be this full distance, then the distance from C to E is going to be half of that. So it's going to be base over 2. So I actually was correct here as well in saying we'll write out our two options. So either we could say the height is 480 divided by the base, or the base is 480 divided by the height. So what we have then is the distance from C to E, we have said, is the base divided by 2, which would be 240 over H. Okay, then my area of my triangle BCE is going to be a half multiplied by the distance from C to E, which we're taking to be the base, multiplied by the perpendicular height, which is the same perpendicular height that we had already. So that is a half multiplied by 240 over H multiplied by H, which gives me 120 meters squared as my answer. So a bit involved there, and a bit of just work in kind of really ironing out all of the points that we're looking for, and kind of identifying that perpendicular height, identifying the base, all of these things. Key things, I suppose, just labeling the sides we're looking for in the first place. But again, finding the area of a triangle, area of a parallelogram, these are things that we should be kind of generally familiar with. So that's why the questions then require us to kind of put that into more kind of complex situations, I suppose. Keeping going, then we'll look at some triangles. So again, as we kind of said with this, with our shapes earlier, with our quadrilaterals, you should be familiar with different types of triangles. You should know how do the sides relate, how do the angles relate. So equilateral, all angles, all sides are equal. Isosceles, we have two sides equal and the two base angles. So the one that's not equal is the one where the two equal sides meet each other. So where they meet at a point, that angle won't be equal, but the other two will. We have a right angle triangle, and we have our scalene where no sides and no angles are the same. Then a few theorems, a few rules that we need to know. First one, all the angles in a triangle add up to 180. That's one we should know. It's one we use fairly regularly. It's one that most people would fairly know. The exterior angle is this angle here, this angle D. And it is the angle that is in line, it's on the same line as the base of the triangle. So you can see we have that straight line. It's as if we extend that straight line out further. And that angle D will be the same as A plus B. And the exterior angle, it's kind of, as it says, there's the extension of one side. So it's when we extend one side out a little bit further, and then we make that angle with the triangle. So you have to be careful that that exterior angle is definitely on a straight line with the side of the triangle that you're looking at. The next one, in any triangle, the largest angle is opposite the largest side. That kind of makes sense, and comes back to kind of, we use that in Pythagoras. So a right angle is opposite the hypotenuse, which is the biggest angle, the biggest side. Same way, the smallest angle is opposite the smallest side, and we can swap that round as well. Then the biggest side is opposite the biggest angle, the same idea. Theorem 8 is called the triangle inequality, and what it means is that adding up the length of this side, DE, plus the length of this side, EF, should be bigger than the length of DF, this side here. Again, kind of makes sense that if we go straight from one point to another point, that should be smaller than going kind of up and then down, up and around. Pythagoras' theorem c squared is equal to ax squared plus b squared. Again, that comes up in your trigonometry. That's one that you've been doing since second year. You should be fairly comfortable with kind of using Pythagoras in that way. So we look at an exam question or two then in answering these. So ABC is an isosceles triangle with AB equal to AC. So isosceles, remember, means the two sides are equal, which is obviously the two sides here that they've labelled in with two lines. If they mark particular sides in with a line with the same symbol, with the same lines, same number of lines, in that case, then that means that those two sides are equal to each other. So AB is equal to AC and BAC is 30 degrees. We want to find ACD. So we are looking for this angle here. That's the one we want to find. So we can see that that's an exterior angle. Okay, one other thing that we know is this angle here and this angle here will be equal to each other. And why is that? It's because we have an isosceles triangle. So we can say that angle B is equal to angle C, and that's because it's isosceles. Okay, so we can also say that 30 plus angle B plus angle C is equal to 180, and that's because all angles, so we could say angles in a triangle. So angles in a triangle add up to 180 degrees. So 30 plus, we'll say 2 angle B, because angle B and angle C are the same, is 180. 2 angle B's is 150, which means that angle B is 75 degrees. Okay, so angle B is 75 degrees, and that means, of course, that angle C is also 75 degrees. And how are we going to use that to find the one that we're looking for? Well, we have two ways that we could do it. We could say angle C plus angle ACD is equal to 180 because it's on a straight line. And that would mean then that angle ACD is 180 minus 75, which means that it is 105 degrees. Okay, or the other thing we could do is say that angle ACD is equal to 30 plus 75, and that is because it is an exterior angle. And we get the same thing again then, that angle ACD, so let me keep that angle sign, is 105 degrees. Okay, let's look at another exam question then. So this diagram shows a parallelogram with one side produced. So that is this side here. They mean by produced, they just mean extended. It's just been pulled out a little bit further than the rest of the shape. So use the data on the diagram to find the value of x, y, and z, and give a reason for your answer in each case. Okay, so we have to give a reason for all our answers that we're looking for. So let's have a look at this one then. So the shape that we have is a parallelogram. So there's a few things we should know about a parallelogram. The first one is that opposite angles are equal. So opposite angles are equal to each other. So what that means is that this angle is 110 degrees. Okay, that angle is 110 degrees. So we have then that z is equal to, and what we'll do is we'll give this one a name. So let's maybe call it B, and we'll say that the size of angle B is equal to 110 degrees, and then we can say that's opposite angles in parallelogram. And we can say then that angle Z is equal to 180 minus 110, which is 70, and that is because they're on a straight line. Those two angles are on a straight line, so they should add up to 180. So we have that this one is 110. We have that Z, which we're looking for, was 70. So that's perfect. We can find Y fairly easily by saying that the angle Y plus 110 plus 30 should be 180. And that is angles in a triangle, which gives me then that angle Y is going to be 40 degrees. Okay, so that's just by taking the others away. So angle Y is 40 degrees. We can fill that in very easily. Then again, we have our parallelogram. So with a parallelogram, we know that this side is parallel to this side, so I can actually use my alternate angles. And using my alternate angles, I find that this 30 degrees is the same as angle x here. So I get that angle x is 30 degrees because they are alternate angles. Okay, and then we found so we found the value of each of them, and we've given our answer as we were asked. We were asked to give our answer for each reason in each case, and we've given that reason. Okay, I'm going to skip over the congruent triangles for a second. I'm going to do those in a separate video. We're just going to quickly look at this rule then with parallel lines and how that relates again to our triangles. So the theorem here is that if a transversal is a line, okay, if any sort of line, so a transversal here that cuts across more than one line. So if a transversal is cut into equal parts by 3 parallel lines, then any other transversal will also be cut into equal parts. So what that means is if I have a line like this one here, this one marked in yellow, if I have a line going straight down like this that goes across 3 lines which are parallel to each other, then if I draw in another line, so this green line, if I draw it across these same 3 parallel lines, it will also be cut into equal parts. Now those parts might not be equal to each other, they could be, but they may not be, they don't have to be equal to each other. What we more mean is that this section here will be the same as this section here. And the same thing goes on the first line, and I've marked them in red there. That section would be the same as that section. So let's just look at a quick example of kind of how that works in practice. So this diagram shows 3 parallel lines and 2 transversals, so 2 lines that go straight across. AB is equal to BC because it divides it into equal parts. And we're told then DE is equal to 6 centimeters. So we have to find EF. And we can simply say that the distance or the length of EF is 6 centimeters. Okay, and why is that? Well, it's because the transversal cuts, or the parallel lines, parallel line cuts transversal into equal parts. So what we're saying is the transversal, or the parallel lines cut this transversal into equal parts, which meant that AB was equal to BC. And if it's the case for one line, it will be the case for any other transversal that's drawn across those parallel lines. So if it cuts one particular line into equal parts, then it will do the same for any other transversal line. So the reason we know that this section and this section are equal is because these 2 parts are equal to each other. That's basically our kind of logic here that we're following. So how that applies to triangles then is that we can talk about, or we can draw a line within the triangle that's parallel to the base of the triangle. So that's what we have here. So we have our base of our triangle here, and we have another line here that we've drawn that's parallel to that baseline. And what we've said from that theorem is that if these parallel lines cut another section into equal parts, then it will do the same on the other side. Applying it to triangles, what we end up with is if we've a line drawn into our triangle like we have here, this yellow line, and if it cuts one side into a particular ratio, so m is to n, like one length of the side might be m and the other n, then it will do the same on the other side of the triangle. So if it cuts one in the ratio m is to n, then it will cut the other side into the same ratio. And how we can construct that is by saying, well, ax over xb would be equal to cy over yb. And what we're doing there is we're matching up the parts of the triangle that are equal, that are kind of represented on the same side, if you understand me in that sense. So ax and cy are the kind of 2 green parts here, so they're the same kind of section on each side of the triangle, so we're putting them on the top, and on the bottom of each fraction is the same part from the same side but matching them up across ways with each other. And the converse of that is if a line cuts 2 sides into the same ratio, then that line must be parallel. So if these ratios are the same, then that means that this middle line is parallel to the base. So again, how did we use this in practice? So we're given a triangle here and we're asked to find the length of x given that DE is parallel to BC, and that symbol there meaning parallel with the two lines. So that means parallel. So we're told that this is parallel, we're asked to find the length of x. So let's construct this for ourselves here. So using my diagram, BD over DA, so this ratio or this proportion is the same as CE over EA. So this is our rule. So if I take one side and write that ratio, and remember ratio and fractions were kind of related to each other. So if I write that ratio as a fraction, putting one section over the other section on the same side of the triangle, that should be equal to doing the same thing on the other side. And we get that CE is equal to EA. Now we can fill in those points. So DB or BD is the one we don't know. That's the x plus 2. DA I do know is 5. And it's equal to CE is 6.6. And this is 5.5. So looking now, we'll continue on here. And I can work out some of these values here. So we can say this is 5. This becomes 6 over 5 when I put it in my calculator. If I multiply across by 5 here, I get that x plus 2 is equal to 6, which means that x is equal to 4. And we'll go back to the question just to make sure. Yeah, we're just asked to find the length of x. So x becomes equal to 4 then. So the key with all these questions really is lining it up correctly in the first place, just setting out the question correctly. Then after that, we can kind of follow it through however we need to. We can solve the fraction using our algebra, but really it's setting it up correctly in the first place. We look then at an exam question that uses that. So in the diagram below, DE is parallel to FG. So let's make a note of that. DE is parallel to FG. So remembering those lines meaning parallel, we've seen it in all these diagrams, just writing it in so that we don't forget. DH is 5, that's marked in for us. HE is 12, HG is 30. The distance from D to F is x, find the value of x. Well, the one thing that we could mark in is that this distance here from E to G must be 18. If the full distance is 30 and this small first part was 12, the other one must be 18. Now what we can use is we know that these two lines are parallel, and if we have two parallel lines here, then if they cut one side into one ratio, they should cut the other side in following the same ratio. And what we mean by that is that if I have one side, so say the HE, the distance from HE over the distance from HG, that fraction should be the same as what I have on the other side, the distance from HD over the distance from D to E. And we can sub in the parts that we know here. So we know this is 12 and we know this is 18. We know that HD is 5 and we know that D is X, which is what we're looking for. Sorry, not D, DF. Excuse me, DF is X, which we're looking for. So what we could do here is we'll multiply this X up here. So it's X multiplied by 12 over 18 is equal to 5. 12 over 18, we can probably simplify in our calculator, 2 over 3, so we get 2x over 3 is equal to 5. 2x is equal to 15, so x is equal to 15 over 2 or 7.5 centimeters. Now another way that we could take this one here is to do some cross multiplication, which might be where your brain went immediately. So multiplying these two and multiplying these two by each other. So we get 12x is equal to 18 by 5, which is 90. And then we get that x is, again, 7.5 centimeters. Okay, so either way it works. They're both the same. They both give us the same answer. And really it's a matter of algebra. What we could also do is setting up that ratio, setting up those fractions at the start. We could flip the fractions and put the x on the top and put the other numbers on the bottom, and that makes it a little bit easier for us to work with. But either of those ways, any of those options will work out for you correctly. So same as I said with congruent, I'm going to do similar triangles in the next video as well with congruent triangles. So really the key takeaways here are, first of all, this example here with parallel lines and how that applies to triangles and those ratios, with, I suppose, this part here being really important. So you need to make sure you're able to set that up correctly. and you're just taking the corresponding sides on each side, or the corresponding parts on each side of the triangle, and writing them over each other in your fractions. Then going back to the parts here from the start, so we had, let me see, so we had, not this part, the different types of shapes, so your different type of quadrilaterals, so you need to make sure you're happy with how all the angles and sides interact in those. Area of triangle, area of parallelogram, and we saw the exam question with that. And then your different types of triangles and the different theorems that are important with your triangles and how they relate to, again, the angles, the sides of your different triangles. So important that you're just happy with all of those different points, that you're able to put those into practice. And again, a lot of them familiar to us, maybe just haven't seen them laid out in this particular way before. So it's just taking the time to kind of go back over those, practice some of the questions, and kind of get familiar with them in that way.